So let's take a look at 5.2 part 1. All right, so when you have a system of linear equations, how many equations are we dealing with?
2.
We're dealing with 2. In general, a system means 2 or more. Right? If you have more than 2, then it gets harder. Then you have to find like the x, the y, and then they give you another letter. They usually call it z. Right? So we're not quite doing that. Right? We're just sticking with a set of 2. Okay? Could be more, but we don't do more. So it's a set of 2 equations, and it has to use the same letters in each equation. Usually we use an x and a y. The reason why we used x and y is because we were doing graphing yesterday. If I could pick any letters and I was doing a word problem, like the football problem and the basketball problem, I might have picked F for footballs and B for basketballs. Right? The letters that you pick doesn't matter. Okay, as long as you're clear about where each letter means. All right, so yesterday, what was the method that we used to solve systems? Not when they gave you an answer and you had to plug it in, but when you had to figure out what the answer was. What's the method we used?
Substitution.
We're going to do substitution today. So that's a method I haven't taught you yet. But what's the method we did yesterday?
By graphing.
By graphing, yes. So yesterday we solved systems by graphing. Okay. Why, and I kind of already said this, but why is graphing not always the best way to solve a system? What can happen when you try to graph 2 lines? Yeah?
There can be more variables.
Okay, so if you had more variables, then what starts to happen is instead of graphing lines, now you're graphing planes, like pieces of paper, and now it starts to get 3-dimensional. So if you had to solve for more than 2 letters, which you don't in this class, but if you did, now you have to graph 3D. That's really hard, right?
How do you graph 3D?
You use like a computer to help you do it. So graphing 3D, that gets hard. But what about just in 2D? What can happen when we're just trying to draw 2 lines and see where they cross?
You could just put the type like 10 on the calculator.
Well, the way we do it now.
Isn't that to be how we do it?
Like when we do it on paper.
Oh.
What can make graphing 2 lines on paper difficult to find where they cross?
Because it's not accurate.
Right, might not be perfectly accurate, right? If you draw your line a little bit off, now your answer is going to be a little bit off. And what about when you're trying to figure out where the lines cross? What could happen?
It could like not exactly be on the point.
Right, it could not exactly be on a nice point. So now it's really hard to find the answer. And there are some problems that have decimal answers. That's very hard to tell graphing by hand. Okay. So answers can be decimals. You need a piece of graph paper, and you need something straight. Also, your answer could go off the graph. So if you have, let's say here's your graph paper, and you start drawing your line, and you have one like this, and you have one like this. Are those lines going to cross each other?
Eventually.
Yeah.
Eventually. But the problem is your graph paper is too small, and it goes off the screen, so you can't see where they cross. So that's another problem that can happen with graphing. Well, we can eliminate all those problems if we solve using a different method. Okay, so we're going to get away from graphing. We're going to learn what substitution is.
Can you graph one forever?
Yes.
What? How did that work?
It just keeps going like a line. It just keeps going. You can't see it because you can only zoom out so far. You can only make your graph paper so big, but it just keeps going. Yeah.
That's crazy.
All right. So another way to solve systems of linear equations is substitution. Okay. So now the next thing I think is what you're going to put on your guided notes. All right. So one situation that you can have, this is situation 1. This is the easiest one, is you don't have to rearrange anything. Okay, what do I mean by rearrange? Well, what letter, when we graph, what letter do we like to get by itself?
Y.
Yeah, we still have to do that when we're doing substitution. we've got to get a letter by itself. It turns out, though, it doesn't matter which letter. You can get the y or the x by itself. I know when you're graphing, it has to be the y. But today, it could be either one. Okay? So, situation 1 is when there's no rearranging to do. And the x or the y is already by itself. It's possible you could have the x or the y by itself in just one of the equations, or both. Okay. So here's an example. If you look at this one, which equation there already has a letter by itself? The top one or the bottom one? The top one. And which letter is by itself?
Y.
The y. So that's an example where there's a letter by itself in one equation. Or if I gave you something like this, which equation there has a letter by itself? Top or bottom? Both. Okay. So in this case, both equations have a letter by themselves. But you need to have an equation with at least one of them having a letter by itself. Okay. If you had something like this, that's not situation 1. That's no good. The problem with this one is you don't have any letter by itself. You've got x's and y's on the same side. That's going to be situation 2. We'd have to fix this one. Okay, but this would be a situation 1 problem. This would also be a situation 1 problem. All right, so how do we do it when it's situation 1? We're going to look for the equation that has the variable by itself. We're going to look for the equation, find the equation that has the variable by itself. Usually it means it's before the equal sign, like right here. And what we're going to do is we're just going to put parentheses around the information after the equal sign. So this step doesn't really do anything mathematically. This step is just to kind of organize our thoughts. So what that step means to do is this. Put parentheses around the information that came after, which means to the right, of the equal sign. So that's all you have to do in step 1. Okay, I'm not actually going to do the problem that's up above because I don't know if the numbers come out nice, but I have one down below where the numbers come out nice. Okay, so first thing is you tell me which equation has a variable by itself. The top one or the bottom?
Bottom.
Yep. The bottom equation has a variable by itself. I want to put parentheses around the information after the equal sign. In the bottom equation, what's the information after the equal sign?
-22.
That's the top. In the bottom.
3x plus 6.
Yep. That's all I want you to do in step 1. Find the equation that has a letter by itself and put parentheses around the information that comes after it. Okay. Any question on step 1? All right. So you can write that down exactly right, just the way it is as we do it. Okay. Step 2. I want to put parentheses around the variable that's isolated in the other equation. All right. So can someone remind me again, in the bottom equation, what letter was by itself in the bottom?
Y.
The y. The y was by itself. So I want to put parentheses around the letter that was by itself, but I want to do it in the top one, just like that. So look at the letter that was by itself, find that letter in the top one, and then just put parentheses around it. The parentheses are there just to kind of tell us what we're going to focus on. Now, can someone read to me, what does that bottom equation say?
Y equals 3x, parentheses 3x plus 7.
Right, y equals, and then in parentheses 3x plus 7. What's another word for equals in math when we write it like as a sentence? Is. So that bottom equation says y is 3x plus 7. It's telling you what the y is. Y is 3x plus 7. Do you have a y in the top equation?
Yes.
Yes. We know what it is. Y is 3x plus 7. So what you're going to do with that 3x plus 7 is you're going to take it and you're going to fill it in for y, because we know y is 3x plus 7. So it says plug in the information that has parentheses around it, that's the 3x plus 7, into that letter in the top. So take the information they give you, y is 3x plus 7, and you're going to fill that information in the top. Okay, so let's write out what this equation is going to turn into. The 6 is going to stay exactly the same. The x is going to stay exactly the same. Plus sign stays exactly the same. The 2 stays exactly the same. Don't write the y. We're going to change the y to something. So leave some room, because we're not going to put y there anymore. The equal stays the same. The negative stays the same, and the 22 stays the same. So there's only one thing that's going to change, and that's the y. What are we going to fill in for the y? Because the bottom equation tells us we can do that.
3x plus 7.
We're going to fill in 3x plus 7. What we just did there, that's called substitution. It's when you take information from one equation and you fill it into the top equation. That's it. That's substitution. Now, if you look at this equation we just wrote down, how many different letters do you see there? Different letters.
2.
What are the 2 different letters?
It's just 1.
Just one? Okay, what's the letter then?
X.
Just x. That's the whole goal with substitution. You started with an equation that had 2 different letters in it, x and y. Now you have an equation that only has 1 different letter. That's easier for us to solve. Okay, we can't solve it if it has 2 letters that are different. They have to be 2 letters that are the same. That's how we have to solve it. Right, so any question on what we did there? Plug in 3x plus 7 for y. Now this bottom equation, we can kind of forget about it for a little bit. We don't need it anymore right now. Okay, we already used it. We'll come back to it later. But for now, we're going to focus on what's in that box. So step 3 is solve the equation that you just made. There should only be one, and when I say one letter, I mean one different letter. Okay? You may see the letter more than once, but there's only one different letter there. It's just an X. Okay? And now, remember, how do you solve that equation? That's the acronym we usually use, SAM. simplify, do any adding and subtracting, and then finish up with multiplying and dividing. Under the simplify step, you may have to do the distributive property and combine like terms. Okay, so let me copy that down so I have some space to work. So 6x plus 2, 3x plus 7 equals negative 22. Okay, so let's go through our steps with Sam and see if we have any of them. So first step under simplify is distributive property. Is there any distributive property in this problem?
Yes.
Yes. What number are we distributing?
2.
2. Yep. Almost all of these problems have distributive property, pretty much. Okay. When I distribute the 2, I'm going to have 6x plus, what's 2 times 3x? 6x again. And what's 2 times 7?
14.
14. Okay, so the distributive property, that's gone. Okay, next thing would be combine like terms. Remember CLT, that's on the same side. Are there any like terms I can put together on the same side?
Yes.
Yeah, what are they?
6x and 6x.
Yep, I can just combine them together. What's 6x plus another 6x?
12x.
So it's 12x. All right, so now we're getting to a simpler equation. The next step would be the A in SAM. Is there any adding or subtracting that you can do?
Yes.
Yeah. What would we do next? Add or subtract?
Subtract.
Yep, subtract. And what would you subtract on both sides?
14.
Yes, we're going to subtract 14 from both sides. So the goal here is we're trying to figure out what x is. We're trying to find our first letter. What does that leave me with on the left?
12x.
And what's negative 22 minus 14?
Negative 36.
Negative 36. Okay, last step in SAM is the multiplying or dividing.
Divide.
Yep, we're going to divide. And what do we divide each side by?
12.
12. 12 divided by 12 is 1, so that's gone. And we get x equals, and that goes in evenly. What's a negative divided by a positive?
Negative.
So it's a negative. What's negative 36 divided by 12? Negative.
Negative 7.5.
So 12 times what is 36?
12.
Yeah.
33.
3. And since this is a negative divided by a positive,
Negative 3.
it's negative 3. So now we know that x equals negative 3. But we're solving a system. How many letters do you have to find?
2.
You have to find 2. Once you find the first one, you're like 90% done. Okay? To figure out the last letter, that's going to be very easy. Go back up. Well, actually, I think I write down what the last step is. So step 4 is plug in the number that you just solved. So in this case, the number that we got was negative 3. So we're going to plug in negative 3 into one of the original equations. Now, I say here you can plug in either for x or y because it depends on what you did in the last step. Sometimes you may get x first, sometimes you may do y first. Kind of depends on the problem. In our case, we did x first. So what letter did we just solve for?
X.
Yep, we solved for x. What letter do we still need to figure out?
Y.
Y. So we're going to take this -3 for x. Let's go back up to the original problems. Let's call this equation 1 and equation 2. Which equation do you think it's going to be easier to plug the x into?
2.
Yeah. So let's just copy that down. Y equals 3x plus 5. What did we just figure out x is?
-3.
Yep. So now, this is step 4. Take that -3 and fill it in right there. Okay, let's fill it in. Y equals 3 times, and what are we going to fill in for x? -3. Now we simplify that, and we'll have our answer for y. What's 3 times -3?
9.
Good. And what's -9 plus 5?
-4.
Perfect. And what did we just figure out? What letter is -4?
Y.
Is the y. Perfect. So now, let's just write our final answer. X was -3, and y was -4. Now, yesterday we wrote that as a coordinate. If you want to write your answer this way, that's perfectly fine. So if we were to draw, we didn't, but if we were to put in the graphing calculator equation 1, and we put this one in equation 2, and we drew it, that's exactly where the two lines would cross each other. -3, -4. So we figured out where they crossed, but we didn't draw any pictures. We did it a different way. Now that's pretty much how substitution is every time. Okay. Any question on that? I don't think we're going to do situation 2 today. I think all we're going to do is situation 1 where there's no rearranging. We'll focus on those. And then tomorrow we'll do the ones that have rearranging. So we're just going to try a few more like this. Okay, so it says solve the system of equations by substitution. In general, if there's no directions on how to solve the problem, you can solve it any way you want. You could graph it, or you could use substitution. But if I'm given the choice, I generally don't like to graph it. It's just not my favorite method to use. Okay, so first step, let's just put this up. Find the equation that has a variable by itself. Okay. Which equation this time has one of the letters already by itself?
The first one.
Yep, the first one. I want to put parentheses around the information after the equal sign. What's the information after the equal sign in the first one?
-2x minus 1.
Yep. So again, there's no real math going on here. We're just putting parentheses around it, basically to tell us, okay, that's important. So we're going to remember, all right, we got to look at that. And now we have to put parentheses around the letter in the other equation. Which letter was by itself in the top one? Y. So put parentheses around the y in the bottom. Now, the top equation is telling you y is -2x minus 9. Top equation is telling you what y is. So you're going to take the information that they tell you, and you're going to fill it in for y in the bottom. Any question why we're filling in that information for y? Take the information that they tell you y is equal to, and you change the y in the other equation to what they tell you y equals. So what's going to happen to the 6?
Six is just gonna stay
It's going to stay the same. What's going to happen to the x?
It's gonna stay
It's the same, and the minus?
Stay
A 5?
Stay
Okay. The y is not going to stay as y. So let's just leave a little bit of space. We're going to fill in that in a minute. How about the equal sign?
Stay
And negative 19?
Stay
Okay, so everything stays the same except what they tell you for y. What do they tell me I can fill in for the y?
Up top.
Yeah.
2x minus 9.
They tell me the y is negative 2x minus 9. So change the y to what they tell me. Negative 2x minus 9. And now we do it exactly like we did the last one. Okay. So we'll go through this one, and then I'm going to give you guys one and let you try it. Okay. Solve this for x. Is there any distributive property? Yep. What are we distributing this time?
Negative 5.
Yes, you have to be careful. The sign to the left always goes with the number. That's what you're distributing. The negative and the 5. Okay. What's negative 5 times negative 2x?
10x.
10x. What's negative 5 times
45.
negative 9?
45.
45. Okay, so there's the distributive. Combine like terms. Are there any like terms on the left that we can put
16
together?
and 10.
Yep, 6x and
16.
10x. What does that come out to?
16.
16x.
X.
Okay, we're done with simplifying. Now we have to start moving things from side to side. Is there any adding or subtracting?
Subtract 45 to 18.
Yep. We're going to subtract 45 on both sides.
That would be 64.
Yep. If you're not sure, you just use your calculator. Plug it in.
Yes, at least.
Negative 19 minus 45 is negative 64. And I'm done with adding and subtracting. Is there any multiplying or dividing?
Dividing.
Yep. And what are we going to divide by?
16.
16. That's gone. And if you take negative 64 and divide by 16, you get negative 4. And what is the negative 4?
It's x.
It's x. What letter do we still need?
Y.
Y. So we're going to take that negative 4, and you're going to fill it back into one of these equations. It actually doesn't matter which one. You'll get the same answer. I would pick the one that looks easier. Which equation does it look easier to plug the negative 4 back into?
The y equals.
Yeah, you always want to pick the one that has the y equals. So take this number and fill it in right there. Okay. So we're going to have y equals negative 2. And then what number are we filling in for x?
Negative 4.
Yep, fill in negative 4. And what's still on the end of that?
Negative 9.
Yeah, we still need the negative 9. Okay, what's negative 2 times negative 4?
8.
Yep, 8. And what's 8 minus 9?
Negative 1.
There you go. And that's your answer. So I think the way it's set up on Edge Elastic, you'll have x equals, and then I'll give you a blank line. Y equals, you'll have another blank line. And you just put the numbers on each line. Negative 4, negative 1. And that's pretty much it. So that's pretty much all the work right there every time for solving a system. It's about the same amount of work you have to do every time. question on 1b. Alright, so let's see. Let me see. So 1c, that's similar to what we did. So is 1d. I'll probably let you guys try one of those. And then, okay, and then there's a problem that we did at the end of the notes from yesterday. It was the one with the small candles and large candles. I'm gonna have to look up what the equations were, but they want us to solve it. Okay, but I'll look up what those were in a little bit. All right, so why don't you guys try 1c and see if you can figure out what x and y are. Okay, and when you get an answer, let me come take a look. Okay, so this one's a little different because both equations have a letter by itself. This one, only the top one did, and then this one, only the bottom one did. When you have two equations that both have a letter by itself, just put parentheses after the information that comes to the right of the equal sign. Take that information and plug it in for the letter that was by itself in the top. That's how you do it. So when I do that, what am I changing this y to right here?
X plus 5.
Yep. So x plus 5 equals, and then what's on the other side?
5x plus 12.
Yep, 5x plus 12. Now there's no parentheses, so there is no distributive property. So what's the first thing that I could do in terms of adding or subtracting?
And subtract the x from the 5 and then add it, no,
Subtract x from
both sides.
both sides. Yep. You can subtract x from both sides. Just make sure that you line all the x's up, because you have to line up like terms. What's x minus x?
1.
0.
0. Yeah, that's gone. So we have 5 equals, what's 5x minus 1x?
4x.
So 4x. Okay. What would we do next to get the x by itself?
Subtract 12 from
Yep.
both sides.
We're going to subtract the 12 from both sides. Positive 12 minus 12, that's 0. And what's 5 minus 12?
-7.
Yep. So we get -7 equals 4x. And what's the last step to get x by itself?
Divide.
Yep. What do you divide by?
It's -7.
4.
No, not -7.
Oh, 4.
4. Yep. Divide by 4. Divide by 4.
Because I always put an X on the other side.
That's gone. And that's it. That's your answer for x. I know it's not a nice number, but that, that can happen. So the answer for x is -7/4. You never would have been able to figure that out graphing by hand. How would you figure out that they cross at -7/4? That's a hard number to figure out. All right, so that's x. What letter do we still have to find?
Y.
We still have to find y. So we're going to take the x, and what are we going to do with it?
Oh, plug it back into the y equals.
Yeah. Which one do you think would be easier? You can pick either one. Pick the one that's going to be easier.
Top one.
Top one, yeah. The numbers are smaller. So take that and plug it back in. Right there. So you're going to have y equals. And what are we filling in for the x?
-7/4
Yep, -7/4. And what do we have to add to it?
plus 5.
You still have to do the +5. Okay, again, your calculator can do that for you, the ones I have. So I'm just going to do it on the calculator. So I have -7/4. I'm going to do +5. And the calculator tells me the answer is 3.25. So I can do it that way, or my calculators can also change that to a fraction is 13 over 4. Because 13 divided by 4 is 3.25. Okay. So you could write it as a fraction, or you could put it as a decimal. I'm just going to do it as a fraction. So there's your x and there's your y. Again, you never would have figured that out. How would you figure out that the graphs cross at 3.25 by hand? But that's really, really hard to figure out. Okay. So any questions before we look at the last one? All right, so the last one is one that we started yesterday. It was the one about the candles. We were selling small candles and large candles. And we came up with these two equations. But I said to stop there. And I said, we're not going to solve it. Why didn't we graph these and try to solve it? What would be hard about graphing these?
The 144.
Yeah, 144, that's a really big number. So if you're going to try to graph this, I mean, that's huge. So graphing is not a good way to solve this one. What's the method that we learned today? Substitution. Exactly. That's a much better way, a much easier way to solve this one, because substitution doesn't care how big your numbers are. Graphing does. Okay, graphing is hard when numbers are big. Okay. So make sure you have those copied down. That's from the last problem yesterday. Which equation already has a letter by itself?
The top one.
Yep, the top one. So you put information, put parentheses around the information that comes after the equal sign. And what letter was by itself in the top one?
X.
X. That's what you're going to put parentheses around in the bottom. Now you're going to take that information and you're going to fill it in for X. So what's going to happen to the 4y when we fill in for X?
Nothing.
Nothing. What's going to happen to the plus sign?
Nothing.
Nothing. How about the 6?
Nothing.
Nothing. The X, yes, something's going to happen there. So leave some room to fill in for the X. How about the equals 144?
Stays the same.
Stays the same. Okay. So now, instead of putting in X, what do they tell us in the top equation, X equals?
4 plus 4.
Yep, they tell us X is 4 plus y. So we fill that in. And now we're going to solve. Okay, so first step, we're going to distribute. So 4y is going to stay right where it is. What's 6 times 4? 24. What's 6 times y?
6y.
6y. Any like terms that I can combine together on the left side?
4y and 6y.
Yep. What's 4y and 6y when you put them together? 10y. 10y plus 24. Okay. What would be the next thing we do on both sides to get y by itself?
Subtraction.
Yep. What would you subtract?
24.
Perfect. So we get 10y equals, what's 144 minus 24?
120.
Yep. And what's your last step?
Divide.
And divide by
10.
10. So we get y equals 120 divided by 10 is 12. And what's the last letter we need to find?
X.
X. So what are we going to do with that y to find x?
Put it in for y.
You got to plug it back in for y. You can choose either equation. You'll get the same answer. But which one is easier?
X equals 4
Yeah.
plus 1.
Always pick the one that has the letter by itself. Okay, so let's do that. So we get x equals 4 plus, what are we going to plug in for y? 12. So what do we get for x? 16. Okay, I don't remember if x was small candles or large candles, but we're going to buy 12 of one type of candle, and we're going to buy 16 of the other type. I'd have to look it up from yesterday.
Sir, we really should like just split the money in half. That's what I did. I split the money in half and still got the same answer.
Oh, okay.
Yeah, I just split the money in half. Then just took whatever the price. Then I just did 4 times 4 minus 3, minus 16.
You got the same thing? Okay. Yeah, it might be different ways to look at it, certainly. Okay. So all the problems that you do in the homework tonight, it will always have one equation with a letter by itself. Tomorrow we'll do ones where that doesn't happen. Okay, so homework tonight is the 5.2 part 1 worksheet. 5.2 part 1 worksheet.